Hello and welcome to this series where I'll be walking you through how to make um, how to create your own server using Fast API. So, of course, in the web we have client-server communication where the client sends a request to the server and the server responds with a response. So, we'll be focusing on the server aspect where we'll be responding to requests from the client. So, the client may request for information that is, they may want to get some information with server. So we can respond with get to allow them to retrieve that information. There can be post used to create information on the server. There can be put to update all the information on the server. There can be patch to partial update of information on the server. There can be delete to delete some information on the server. So without much further ado, let us proceed in creating our own server. So to walk you through my folder structure, I have Alembic, I have db.db main.py, bibfile.log, and then on the bib file, the c.py and c.py. So Alembic is a folder that is generated when I'm migrating my folder, sorry, migrating my database from one state to another. There's db.db where SQLite is storing my actual database. So this is a file that SQLite is using to store my database. There's main.py where I'm going to write the code. So this is it. And then there is pfile and pfile.log for managing dependencies. There's c.py, which of course are used for database migration. So I already have some data here which I had migrated using the c.py file. There are quite a number of them. And then there's a student.py which contains my student model together with the configuration needed to work with my database. So without much further ado, we'll proceed. So the first step in working with Fast API is to import the Fast API class from Fast API. So we're going to import Fast API class from Fast API. After importing this, we'll create an instance of it. I don't know why my tab is not working today. My tab, for some strange reason, I decided to just be quiet. So after creating an instance of it, the next step is to create functions. So these functions are going to be decorated with the app in with the Fast API instance. Oh my God, who did this? With the Fast API instance, and then of course and then after that we'll have the corresponding method. So it may look something like this. So at app, and then dot, and then the corresponding method, it will be get, it will be post, it will be patch, delete, or some other function. So that is the syntax for creating an endpoint with Fast API. So we'll proceed. So of course I'll create the first function as an example one at app.get. So this is for the root. So if someone accesses the root, want to provide some information, I'll call this function root. Then of course I'll return a simple message. The message will be, someone can't spell message. The message will be welcome, simply welcome to Fast API. That is it. So when you go to this endpoint, you should get welcome to Fast API. So let me run my server. So run your server uvcon, which is the tool that we use to run our Fast API app. Main, then the app itself. So there's the main, which is our file, and then the app itself. And then of course we can add reload here to reload our server on file change. So currently our server is running. So if I access this root endpoint, I should get our message. So there's our message, welcome to Fast API. But of course, it's not a matter of just adding simple messages to Fast API, to giving simple messages like this to our clients. We want to be able to supply the client with student information. So this is student information. So we want to be able to supply the client with student information and allow them to also make some changes. So the first route we'll create is one to get all students. And then the next route will be to get a single student. So let us look at how to go about this. So we'll the function's name will be get all students that way. And then we'll decorate it with the app.get to make it an endpoint. And then this one will go to the students. Then we'll go to the students endpoint. So when you go to the students endpoint, we'll get all student information. So the way we'll retrieve all student information is they will return it is by first of all retrieving it. Then after retrieving it, we return it. So we get the students from our database. So we'll import two things from our student model. So from student, we'll import the student model together with the session to interact with our database. So this variable here will assign it the value you get when we query all the students in our database. So it will be session.query and student then dot all that way. So this should return for us all the students. So if you navigate to this endpoint, you should be able to get what? All the students. Voila, get all our students. So the next one is to get a single student. So to get a single student, the same thing. So we decorate a function in the app.get. Then in this case, we have students, and then we'll pass some parameter, which is the admission number of that particular student. Get one student, and then of course we'll take our admission number and cast it into an integer. Then we'll use it to query our database. So we'll simply do, so we'll keep a variable called student and assign the value you get when we make a query. So session.query, when we query for that student, that particular, with the past ID, session.query, then we'll query the student model, and then we'll filter by where the admission number is equals to the admission number that is first. Then we'll need the first one that way. Then of course, after getting that student, keep on pressing shift with enter, we'll return that particular student that way. So that is it. So this is how we get one single student. So we get a parameter from the user, which is the student ID. We cast it into an integer, and then we use it to query for where the admission number of that student matches what the admission number that has been passed, and then we return that particular student. Of course, there's a fallback for if the student is not found, but let us first of all confirm if it is working when we go to the fallback. So is go to students, and then I need one with the ID of 4. Server is just quiet. It's not happening. PP is not defined. What is this? Is this PP? Oh, sorry. Hey, I missed that app. That app.get. Hey, yeah. So now we have our student. Then, of course, after that, we have to create a fallback case for if the student is not found. So for that, we have to import something from fastapi, the HTTP exception class, HTTP exception. Then of course we'll confirm if the student has not been found. So if not student, what do? We raise an exemption. We don't return, we raise an exemption. We raise HTTP exception, and then the status code will be equal to 4 for that is not found, and then the detail will be student does not exist in our database that way. Student does not exist in our database. That should be okay. So let us confirm. So I think I don't have one with the ID of 100. Navigate student does not exist where? In our database when we try to navigate to that particular page. That is how you simply raise exceptions. So you raise the HTTP exception, you don't return. I hope that is okay. Now, the next thing is to work with schemas in our fast API model. So of course, we want to be able to tightly couple the type that will be received and uh, passed, sorry, the type that will be, that these our functions are going to return. In order to do that, we must import our the base model from Pydantic. So from Pydantic, we'll import base model. Then we create a model. So this our model should correspond to our ORM. Sorry, our student model, which is, I keep on pressing shift and enter. I think I've just gotten used to it. So class student schema plus student schema, of course it inherits from base model. Then of course our student schema should correspond to this type, since that is what we are returning at this particular point. So we will simply create the fields with the corresponding type. I forgot again, press the wrong button there. Then we have first name, which is a string, last name, which is a string. Then we have age, which is an integer from what you see, and then course, which is also a string, Now, since this is data from an ORM, we should add this class of config, so that our application, our routes will know that we're working with what, a model from some database. So class config, then ORM mod equals 2. So you're able to access our details with maybe admission number dot or last name dot. If we hadn't added this, of course, it will not be possible to use the dot notation to be able to access our fields, since this one represents in forms of what, how do you call it, data class. Now the next thing is to annotate our types. So this one is supposed to return an array of students, and then is supposed to return what, a single student. So we'll annotate this using the student schema. Now, if you can't remember, this one was returning what, an array of students, but this one is what, a single student schema. So to annotate this, we need a list from the typing module. So from this typing module, the core typing module, you want to import list. So we'll use list here to annotate this function. So this one is going to return what, a list of students, and then this one will return just a single student, that way. So now if I go and confirm maybe one with the ID of 15, it's okay. If I try to access all of them, things are just okay. What happens if I was to remove this class config rm mod equals true? So I'll come here and then reload. I get an internal server error. Why? Because now our Pydantic model doesn't know how to translate the, what do you call it, this data into what, an instance which is composed of attributes, that is using the dot notation. I think that is all to do with fast API in terms of GET requests. So the next one we'll look at post and put and patch requests. We'll look at post, put, and patch requests.